Density is a fundamental concept in science that describes the relationship between an object's mass and its volume. It is a critical property that determines whether an object will float or sink in a fluid. To help students grasp this concept effectively, a virtual simulation can be designed to explore the density of various materials, such as rubber duck, wood, ice, egg, granite, and titanium, when used as the sinker of a fishing rod. This simulation not only makes learning interactive, but also visually demonstrates how density influences the behavior of different materials in water. The simulation begins by allowing students to select a material for the fishing rod sinker. Each material has unique properties, such as mass and volume, which directly affect its density. For instance, a rubber duck is lightweight and has a large volume, making it less dense, while titanium is heavy and compact, resulting in high density. Students can vary the mass of the sinker during the simulation, observing how changes in mass impact the object's density and its ability to float or sink. As the simulation runs, it generates a graph plotting mass, g, against volume, ml. This graph visually represents the density of each material, calculated using the formula, density equals mass/volume. For example, when students select wood, they will notice that even with an increase in mass, the volume increases proportionally, keeping the density relatively low. In contrast, materials like granite and titanium show a steep slope on the graph, indicating high density due to their significant mass and low volume. The simulation also includes a virtual water tank where students can drop the sinker made of different materials. They will observe that low-density materials like wood and rubber duck float, while high-density materials like granite and titanium sink. This hands-on experience reinforces the concept that density determines buoyancy. Additionally, the simulation can include intermediate density materials like ice and egg, which may float or sink depending on their mass and volume, providing a nuanced understanding of density. One of the key features of the simulation is its ability to demonstrate real-world applications of density. For instance, students can explore why ships made of steel, a high-density material, float, because their overall density is reduced by their large volume and hollow structure. Similarly, they can understand why a small titanium sinker sinks rapidly compared to a wooden one. By engaging with the simulation, students gain a deeper appreciation for the importance of density in science and engineering. They learn to predict and analyze the behavior of materials based on their density, enhancing their critical thinking and problem-solving skills. The interactive nature of the simulation, combined with visual aids like graphs and real-time observations, makes it an effective tool for teaching the concept of density in an engaging and memorable way.